Hello. I think we're live now. Testing 1, 2, 3. 1, 2, 3. Ooh. Testing 1, 2, 3. 1, 2, 3. Ooh. Testing 1. Okay, yeah. I can hear myself. Let me know if you guys can hear myself as well. I think the quality is alright. I'm not too sure. Anyway, good evening, everyone. Let's put this always on top. We're Gucci. Okay, good. So, welcome back, everyone, on the stream. Today we're going to be doing some more C++. So, stream okay. Thank you, dude. Yeah, let me know if the voice is shit. Cause sometimes, for some reason, OBS decides to turn the quality down of my microphone. So it picks the headset quality. Sorry, yeah, the headset quality instead of just recording quality for some reason. It's a really odd one. Anyway, nice to see you, GTX, and welcome, dude. Hope you're having a good Friday, a good Saturday, right? I've lost track of the days. Voice is the same as always. Nice one. Hopefully it's good. Yeah, so today we're going to continue working on the visualizer stuff. Let me take you guys where I stopped, right? So I think it still all compiles. What does it? I think I started making some changes, so it might not always compile. Or we can fix those real quick. Size of valid application. Instantiation of unique pointer. No, for declaration of keys FFT state. Yeah. Okay. Don't see why this is not compiling. FFT state. Okay. I just missed the name. Probably. I finally solved the issue with my project. I no longer get impossible results all the time. That's pretty good. That was pretty quick, to be fair. I think you've mentioned that this afternoon, right? So for you to fix a complicated mistake in a few hours, man, should pat yourself on the back for sure. Yeah, so it did compile. No, it doesn't. It no longer compiles. We're gonna fix that real quick though. So in here, I'm just having an issue with some for declaration of this KISS state thing in here, which is on a unique pointer. And KISS a lot is returning what? It's supposed to be CFG, not state. That is why. I got the type wrong. So yeah, just a little bit of context for you. So I've added this library called KISS FFT, I think it is, which does it just does FFT analysis, right? And I've basically turned off all of my implementation of FFTs because I thought that wasn't working fine, but it turns out that it was working fine. It was just conflict with type there for the same name. Wait, what? Analysis CC. What the fuck? Type def struct, which is just a C. Stay. Oh, it was correct. It's supposed to be appointed to KISS FFF state. That is correct. I don't see what's wrong here. Now I only need to hammer out another thing. I turn collision off after the first collision because I don't move out of the ball. Don't move out of the ball from the top properly. The issue I was talking about was what I was raging about. Oh right, I see. I thought you fixed that one. I thought that was just an index mistake. But yeah, let's try and get this fixed. Yeah, so my intention here, right? We have, as I said, we've got this header, which is FFT. There's this allocation function, which is what you use to create the object that actually does the FFT. And there's a type there to a pointer of KISS FFT state. and that is a struct, which means that luckily, right, we should be able to do that. Case FFT state. Why does that not work? Yeah, that gives me an error. Because then I actually, obviously, I include the header in a CC file, just typical for declaration stuff, and use the function caseFFT alloc to actually return me the pointer to that thing, right? And that's stored inside the case configuration, which is the unique pointer for the forward declaration. Now I only need to hammer out another thing. I got that. It's the same issue with my project. You think that one part of your code is bad, and then you change it up, the issue persists, and you have to find the real issue. I think I learned that your general thinking is okay, and typos or misinterpreted external library functions cause all the issues. Wait, what? I think I learned that your general thinking is okay, and typos and misinterpreted external libraries. Yeah, that's true. That's true. Yeah, I agree with that. I think most of the bugs I have are literally because of typos I made or like assumptions that I've had that were wrong. In fact, I've got a good story to tell on that particular point. So I had completely gotten rid of port audio, which was the audio library that I was using before, and I put in miniaudio, which is another audio library that's kind of just a single header thing, right? Let me see if I can find it here so as to show you guys. And I was trying to use their circular buffer. First of all, it's like a C library, right? So it's very difficult to use it anyway. Like it's not easy because you have to work with, I guess, low-level pointers and things that you don't normally work with in C++ if you're doing it right, abstracting things. So I had to learn that library, and yeah. So there is this particular function here called acquire write. This is what acquires a pointer to the buffer for you to write stuff into. And this is the circular buffer, that is. It turns out that this write size here, like I thought from reading the documentation of this function, I thought that the write size would be returned as the number of bytes you can actually write. But it does that as well. So it does do that. So like if you only have 100 bytes to write in the buffer, it will return 100 for you. But you're also supposed to preset it to the number of frames you want to read as a maximum thing. And I wasn't doing that. So this was also always returning 0 write size. And it literally took me like 3 days to figure out that I had misinterpreted how this function works. And it was insane. So to reiterate, I agree with your point there. That most of the bugs are caused by typos and misinterpretation of libraries. Oh yeah, I can vouch for that for sure. Invalid application. I don't know. What is going on here? So this is supposed to be case FFT CFG, which is just a pointer to case state. Huh. Is this not type definite correctly? Is FFT state? Right. Let me see. I think there is some sort of issues with my type defs and C type defs. So C++ forward declare C struct. Right, let me see how to do that. Oh, in fact, it's probably easier if we use Claude in this case. Claude will get to the answer a little bit quicker, I think. Do you have a good way to draw a circular buffer on a graph? On a graph, IMplot can only handle continuous chunks of memory, so I can't draw a circular buffer. Oh, I see. No, I mean, you can go through your buffer and put them all in a single array, I guess, right, and then draw the array. But yeah, that's the thing with circular buffers, is this joint, right? So you might have contiguous memory for the most part, but then you might wrap around, which means you can't put it in APIs that usually take contiguous arrays. So yeah, how to forward declare, I guess, a C struct from a third party library in C++. Because maybe I'm missing something here. Yeah, I've done that. See, yeah, so there's no C++ struct third party. And then in the actual C++ code, the implementation, we have a pointer to that. Yeah, so I don't see what we're doing wrong here. It is odd that in their header, though, they don't actually have the struct definition, just this. I guess, right? It's just really odd. Does KISS FFT have a documentation? I just move the data into the buffer. See, move is not that bad. Yeah, no, move is not that bad. Or memcopy is the. I mean, move. I don't know what move does, but memcopy is usually the one I would personally use. To be fair. All right. Do we have KISS FFT state anywhere? Where is that? There you go. That's in KISS FFT gut.h. Do we have that included somewhere in here? We don't. Okay, so this is itself a forward declaration. I see. All right, interesting, interesting. So I can't declare a forward declaration. What? Why not? I was hoping to be able to hide it. Defines KISS FFT scalar as either short or float. And defines the struct we have KISS FFT state. Int factors. So we have a bunch of integers, 2 times maximum factors. No idea what twiddlers are. Interesting though. Yeah, so basically I can't. There's no way for me to actually get that in a unique pointer because I don't. By the time it comes to my C++ compilation, I don't know what the KISS FFT allocation is. Yeah. I guess I could store it. I mean, for now, to get rid of it, I could store it as a void star or something. Right. I guess I could do that, but that's kind of not what you want to do, I guess. Hate doing that, but it is what we're going to have to do. Oh, I've missed the chat. I've missed the chat. Sorry about that. Memcopy would probably be better because memmove is used when source disk can overlap. Yeah, I can't remember what memmove does, but yeah, if they can overlap, then for sure, yeah, you don't want to move shit. Right. What is KISSFG? Okay. So what if we do... Yeah, we're nearly there, I guess. Build... Yeah, this is the problem now. We just got to make sure that we static cast that to a KISS. In fact, what does this take? KISS config. Yeah, okay. Static cast to a KISS FFT CFG. Right, let's try that. It's going to get further. Okay, good. Yeah, it does mean that we have to kind of actually explicitly call free on the config object here. Maybe remove pointer CFG would work. Remove pointer T. What does that do? I don't think I've ever used that. Well, hello, dude. Welcome to the stream. Remove pointer T. Sounds like it's something to remove the pointer. Provides the memory. Oh, right. I see. It's a type trait. Yeah, it's a type trait that will remove the pointer from a type and then just return you the type itself. Yeah, but the problem is that I still want to forward declare it. And if you remove the pointer, you still need to know the size of the state, the KISS state thing. And that is hidden. That itself is like forward declared somewhere within his library. And for some reason, I can't compile it. I'll figure it out later, but I don't think remove pointer will do here. But yeah, I mean, I just wanted to compile to show you guys what we actually have here. We have something that actually shows some audio, but oh no. We can't. That is music that is kind of copywritten, I guess. It's craft work, so let's not put that on so we don't get a YouTube warning. So the Brazilian anthem should be okay. Let me make sure that I've got the right settings for the stream as well, though. Stream settings, boom, 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 boom. Okay. I'm just checking the monetization stuff because if I turned it on and I played that song, yeah, I don't know. It was less than 15 seconds anyway, so we should be okay. There you go. Turned it on anyway. Let YouTube insert rows, balanced. Like, great. So you guys, let me know if the quality hasn't dropped. But anyway, we should be able to start it again. I also want to check the audio here. Make sure it's not overriding. It's not great. The Fourier is definitely fucked. I don't know what's going on here, but I can kind of rotate this a little bit with the mouse as well. There's obviously something going on wrong with my analysis. There's always the, let me see if, can I pause this? The frequencies you see are always like around 0, half, and then the very end frequencies. So, doing a little bit of research online, I was advised to kind of implement a windowing algorithm, right? So we have things like the Hann Windowing algorithm, and also overlap or do a buffer overlap every time. So let's kind of talk about these a little bit on Excalibur or something, right? Just to show you guys what I actually mean. Use logarithmic scale. Yeah, no, that doesn't work. I always min-max things, and it is to do with the window size that I'm using. I think is probably too big. And also I have no overlapping enabled and no like phasing out of the windows, right? So kind of like this, right? So if we have like a very big array of samples, in fact, let me just make this a little bit prettier, right? So if I do that, say we have that, then we have like a bunch of these, I guess. That's 4 here. All right, copy that. There's 8 here. Oh gosh, that looks ugly. Another 16 here. Fuck. Let's double it just once more, right? So we have a big array. Big, huge array, right? And say that inside use logarithmic scale. I've got that. Didn't miss anything. So we have like this window. I guess this is the buffer that I'm talking about, right? Say I was doing 4 for 8 of them, right? So currently my circular buffer is literally just reading whatever's playing on the array and adding it to itself. So that's what I'm storing in the circular buffer, just the interleaved data of audio, right? So you always have like a left and right audio sample, left, right. And I take, I think it's something like 2048 samples. So in other words, 1024 samples per channel. And yeah, I literally just read it once, analyze it, and then go to the next window. Analyze it, go to the next window. You get the gist, right? So literally doing that all the time. Which I guess isn't great. Because you don't have any like temporal accuracy, I guess. I think that's what it's called. I'm not too familiar with it. The output should be different sine waves. Yeah. So this is what Fourier transforms do, guys. This is the bread and butter of what we're using here. Hey, anyone tried fuzzy? Oh, okay. That's why am I reading Discord right now? Let's focus on chat here.
Are you prior?
Please, reading Discord. There you go. I'm on the analysis page. Thank God. Yeah, so what we're using is like the Fourier transform, right? This is what we're doing. And it literally just takes an audio sample, a window of audio samples, and tells you how much energy there is of the sine waves, sine and cosine waves of that frequency on the wave you're doing, right? So basically it decomposes the audio waves into sine waves. You are right. But what you get at the end is actually something like, let's see if I can Fourier transform audio. Let's see if we can, yeah, you get something like this, right? This here. Let's get a better example there. So like you get the frequency of the sine waves and then how much energy there is of that sine wave in the audio window you gave it, right? So it's a very, very nice way to analyze how much, how much of each frequency there is in each of the windows of your audio. And that's what audio visualizers do. However, in my case, we're not seeing something nice like this, as you can see. We're seeing something like all over the place. So most of the energy is in 0, and then we go to the middle as well, and then some at the end, which kind of makes me think that the windows that we're analyzing are not very good. And as I said, it's because we're probably just taking the audio, going to the next window, analyzing it, and so on and so forth. What people tend to do when analyzing audio, and I'm not sure if this is going to fix my problem at all, it might make it better. It might be that there is something intrinsically broken with my code, I don't know. What people tend to do is they will usually analyze a window and have an overlap on that. So instead of like moving to the next one, there will be like a 50% overlap, right? So they only move, 50% of the way, and then another 50% of the way, and another 50% of the way. And while doing that, you also have a windowing algorithm, a coefficient algorithm that you times your window by to actually get some nicer data, right? Some more defined frequencies. So one of them is the Hann frequency. The Hann frequency is something like this. Do I actually have it here? I think I probably did. Hann coefficients, there you go. Hanning coefficients. So if I run this, so what we do here is like there is this nice algorithm where you generate an array that is the same size of your window, or float, or whatever, and then you apply an inverse, well, it's not really an inverse cost function, but you apply a cosine function to get a number between 0 and 1, right? So on the edges, you will have numbers that are very, very close to 0, meaning that those samples that you times things by will have no effect on the transform, basically, like the ones at the very ends. And the ones in the middle will have more of an effect. this is what it looks like. This is what we're going to be applying things to, right? So Hann, if I do plt.plot and coef, I think it is. Let's just code that. Okay. So this is what we're going to be doing. So we're going to be applying this to the window. In other words, we're going to be concerned mostly with the frequencies in the middle of our window, right? Times it by the samples, and then Fourier transform this, as well as applying that windowing, like 50% overlapping. And I think that should give us an audio visualization that actually looks a little bit nicer. This is, you know, just what theory tells me. This is what my small research told me, but we'll see. Which have different intensities, and those sine waves from the original sound. Yeah, so everything in the original sound is going to be decomposed. Ah, so they get better interpolation between the computed values. Indeed, yeah. So you have less noise, basically, call it that way, which I think is what's happening to the current method. We're just getting very, very high noise, which is not ideal. But yeah. You just lost all the viewers, but very interesting. Yeah, I lost all the viewers. I don't really care. I'm here today to actually code. I just want to focus today. So there won't be much chatting today. That's what I'm trying to say. There will be actual focusing, which is good. So this is why I create this class, right? This class is basically something that will allow you to analyze a window of size 2048. In other words, you know, it's assuming, let's put it here. So we assume that our window size in frames is 1024 per channel, 2 channels, right? I will keep the chat live until I go to sleep. Thank you, dude. I appreciate that very much. So yeah, it lets you analyze a window of size 2048. So what we need to do is we need to create that Hann array, right? Maybe at runtime, maybe whenever we create. Yeah. So maybe whenever we create, the class will have that Hann array in here somewhere. And we're going to apply a preprocessor. So the pre-processing of the audio step before we analyze it with KISS FFT will be timesing by the Hann cos wave thingy that we've got here. And the post-processing, so we analyze it with KISS FFT, and then after that we can do a logarithmic scale or something like that, right? We don't really know yet. Whatever makes it look nicer, that's what we're going to do. So yeah, let's begin. So I already did the code to analyze it, because quite honestly, I already had it on the main function, so it kind of works all right at the moment. What I want to do is I want to create I want to let users have the ability to create their own Hann coefficients, right? So this is something I was trying on earlier on. We have an array make Hann coefficients here. So we're going to keep that on the analysis. I'm probably going to delete this file because I don't need it anymore. Yeah, don't need them. So this should apply the formula that I just showed you. So the formula in here, if you want to pause it and see it, that was just doing it with NumPy. Now we're doing it with C++. Which means we have essentially got everything to actually do an analysis, right? I'm hoping that's that we've got everything. So I'm going to look at where I was doing the transform earlier on, which was here, right? So I commented all of this code out. Just going to put a mark here. So this is where we do the sound analysis, right? By the way, I'm not sure if you guys have seen this, but I've started using these things lately in Visual Studio Code. Like you can put marks, and then you get like a little thing on the side. It's good if you have like files like this where it's very, very messy and you have like thousands of lines of code in one file that you haven't yet kind of refactored, I guess, which is the plan for this file. We are eventually going to refactor everything, and it's not going to look as messy as it does right now. But yeah, so marking sounds pretty good just because things are kind of organized. You can see where things are, and later on you can put it in different files or whatever. So yeah. So the first thing we're going to do right? We're outside the game loop. We have a game loop for the visualizer. We're probably going to include, no case FFT anymore. We are also going to remove the functions I had for using case FFT straight away in here. I think it was normalize audio. There you go. So this function is no longer needed because I moved everything to that class anyway. So you guys kind of are aware of what I'm doing. Then I will include analysis here. Remove matrix, remove Fourier, DFT operations. I don't need it anymore. Maybe in a later stream we'll actually try and re-implement the Fourier transformation, because I do actually have a library for it, but I think it's slightly broken. It doesn't work very well. It's something I've written kind of like 7 years ago anyway, so I'm not too bothered. Okay, sort those out. Okay, so we're missing some CMake here, I think. So wave tune graphics. What is the analysis thing called again? WT. Maybe I should have called it wave tune actually. Okay, we Gucci. Wavy tune. What did I call it? Analysis, right? Or something. I'm gonna make sure this is all sorted. Wait, why did it not sort? Okay, good. I just navigate to my repo by holding control and clicking on anything I want to go. I use Sea Lion. Bookmarks. I don't know what bookmarks are in Sea Lion, dude. But this is just marks, I guess. Yeah, kind of like a bookmark. I guess that is the right word for it. So let's include analysis, and I think what did I call it? Hann window? Yeah, there you go. Now back to where we had the sound analysis. Move these renderers. We don't care about them anymore. We are going to create a WT analysis FFT analyzer. Let's do the American spelling, I guess, right? Good. So we've got the analyzer. Now we come down here, and ideally we want to call the analyzer, I think .analyze, that's the one. But first of all, I think we called it raw audio. That will do, right? Yeah, good. I was wondering if you guys want me to actually put the camera on my typing. I'm not sure if that's interesting in the stream later on. I'll see. So now we don't have that anymore. I'm going to leave that as is though. So we've got that. We don't want this anymore. Oh no, we do. Do we? No, we don't want this anymore. Buffer lock, fast FFT. Yeah, we don't want that. We've got heights. Right. Yeah, one thing I forgot to do. Oh, what is this now? WT, FFT, analysis. Can't type analysis. Dot window size, yeah. That's the one. Okay. Bought that keyboard. Yeah, dude, you did. Let me see if I can set it up, actually. I don't even know what my other camera is, to be honest with you guys. Yeah. I'll do it some other time. Right now, it does look pretty, though. I'm not sure if you can see it, but this is what the keyboard would be looking like today. Oh, no. It's getting rid of... What? Okay, it just selected the wrong camera. That is not ideal. So just by moving my camera, we messed it up. Right. Let's see if we can fix it now. Jesus. God damn it. There you go. I just wanted to move it and show my keyboard. There you go. I've got a really nice kind of color scheme today, but we're not going to be able to do that. Does it also glow? Yeah, it does glow, yeah. Did I not mention that? It does not only glow, but you can also set a bunch of stuff. Let me show you. So I think it's Epo Maker. There's a driver thing you're going to get with it. Epo Maker driver. Hopefully I'm not going to be releasing any information here. And yeah, you can kind of like do your own lights on it. And there is a screen, by the way. There's like a nice little screen you can put GIFs on. I've got like SpongeBob running. But yeah, dude, like you can set your own lights, put it that way, the light edit, and then you can put your own colors and whatnot. And frame rates. It's really good. Is that candid shot of the frames glass of Diet Coke? It is, yeah, it is. I have run out today though. No more Coke Zero. Anyway, we're good now. So, got what I was doing. Yeah, here. So analyzer, set preprocessor. I want to set a function that will take a stud array of STD complex, I guess. Flow of const. Oh. That's the array flow const. Right? Do we have array? What was the issue here? No variable conversion from this, even though we had WT analysis, window size here. I just can't spell. So window is the word of the day that I just can't spell. There you go. God damn it. Yeah, IntelliSense is nice. I'm happy now. So this is where I would like ideally, you know, this is the to do here. To do, we want to apply the Hann coefficients to the array, right? So what we do is we want to get the coefficients in the first place. So also const Hann coefficients WT analysis make Hann coefficient. What did I just call it? Is it not in a namespace? It is that. I'm gonna put on some anime girls on there. I can finally have fancy keyboards instead of gaming keyboard. I'll probably use this keyboard for the next 8 years. I've been using it. This is my first year with it, actually. For some reason, my phone reminded me the other day that I had bought this keyboard a year ago. I think I took a picture of it or something for the stream. And yeah, it's officially a year, first year of the keyboard. And I'm still enjoying it, dude. Like, it's very satisfactory to kind of type in it. And did you get the yellow, what was it called? The Gateron yellow switches? Or did you get a clickety-clackety one? I'm guessing you got to choose, right? Because I got to choose the switches, and I chose the yellow ones. And it's just so good. Really, really good. Yeah, so why are we not getting the make? Why are we not getting this? Make Hann coefficients. Hann window. I am including that in here, right? Hann window, yeah. We are. Right, that's odd. That is odd. Very odd indeed. No template named make Hann coefficients namespace. Did you mean make Hann coefficients? Yes, I did. I did in fact do that, yeah. Oh, it's because it's, yeah. I'm an idiot. It's WT make Hann coefficients. There you go. That's why he wasn't finding it. I have no idea. This was a discount shop. Well, luckily for you, right? What you can do is you can get a keyboard out, get a keyboard out when you get in, take the key out and see the color of switches that you have. And if you don't have anything but the yellow, you can go and get some. I think they are just the Gateron yellow switches, right? So these ones here, right? So you can buy them on Amazon. They're only £18, which should be around, what, 20 euros or something. And you get the same keyboard I have with the same quietness, because it's not very loud. It's very, very quiet. But it's really satisfying. So I would recommend changing your switches if you didn't get the right ones. So yeah. And we kind of want to take anything here, right? So what we do is, I guess for each I guess std size t equals 0, I less than wt analysis window size. We're going to do something like this, right? So array, we don't want to call it array for sure. I'm not sure if that's going to buffer, I guess. Buffer I. We're literally just going to times that by the Hann coefficients at ith position as well. That's it. Right? Yeah, we can do that. Right? Yeah, we can do that. We can do that. Because that's my preprocessor, right? So in theory, this should work a little bit better. A little bit better. Let's see if it compiles, shall we? Bin pack to 100 is not working there. What are we going to get? There are pictures of those on the page, so probably. Nice, yeah, that's good, that's good. Yeah, so what is the problem here? So bin pack is just some function I've written, right? Because what you get from this analysis, this whole analysis thing with KISS FFT, is an array of the same size as the input, but each index is a frequency instead of, you know, the time sample. So essentially, we get an array that has size 2048. Not ideal, of course, not ideal. 2048, which obviously we can't show on the screen. We don't have that many. So what I do is, like, I get those 2048 arrays and bin pack it to only 100. And this is the function that does it, bin pack. It's very roughly written. I'm pretty sure there's probably a bug in there somewhere, right? I don't really care too much, but we're getting an error nonetheless. So no member named matrix in WT. And that is the first issue. So matrix to vector. We don't need that anymore. Pretty sure. In fact, we may not even have an issue at all. What is that taking though? Array, in size, out size. So the out size is that. What is the transform? Transform is what size though? Ah, it's a complex. That's why. It is a complex. All right. So what we're going to have to do is we're going to have to convert that, I guess, into a buffer. Oh my god, yeah, we're going to have to convert from the complex buffer to a float buffer. In other words, we're going to sum the, yeah, that's fine, we can do that. So let's do a post processor as well, right? So analyzer dot set processor. set post processor. There you go. So this is the same thing. It takes like an array somewhere. So I think it has to be array of std complex of float. I think that's what it returns. Obviously in here we want a WT and the size of the array, which is analysis. Windows size, nearly spelled size correctly this time, thank God. Yeah, so what we're going to do here is actually, we're going to convert the complex output of the analysis into a single number, right? And that single number is just going to be the modulus of that. Because actually what you get, by the way, for sine and cosine, I think the real part of the analysis is the cosine frequency, and the imaginary part is the sine or something like that. Yeah, cos plus I sine. Yeah, it will be that. So we can just do the energy, right? So I guess, yeah, how much energy there is. In other words, the modulus of the number. Issue is that I will need to get used to using the numbers in the main part and not the num part. I tend to use home and end a lot, no separate key. But I have you do have the D-pad, if that's what you mean. Like there is a number thing, right? It's just a little bit smaller, but you do have those numbers for sure. Yeah, so again, we're going to do some sort of like array like this. Let's just paste it here. So yeah, so buffer I.real. Does that work? Wait, how do I set the actual real and imaginary? std complex C++. Member functions. Real access is the part of that. Non-member functions. Can I just do real equals whatever? It won't work, right? There's no way. Yeah, returns a constant. So is it? Essentially, I want to reassign. Oh gosh, this is why AI is kind of good now. How to reassign a value to the real part of a complex number in C++. Std complex float. Boom. Your keyboard doesn't have the separated. Yeah, but I use separated home and keyboard. Okay, that's a weird setup. You're gonna have to send me a picture, dude, because I don't know what you mean. Modify the real. Oh, so it does take. Okay, I'm too stupid to actually have seen that here, right? Where is it? Oh, this is remove pointer though. C plus equals 2. That's a new language dropping for you guys. Ah, yeah, he does. I'm an idiot. Never mind. I'm a massive idiot. So real should have been buffer.I I guess result is buffer I. I will copy things for sure. But do I care? No, I don't. I also did 3 Fs instead of 1. Come on, guys. I thought you meant to be helping me out here. This is the result. The real. Is the square root not a thing? Do I have mapped in here? Yeah, we have CMap in here. That's going to be the res.real times res.real plus res.image times res.image. Right? Correct. And it's the square roots of the whole thing. Yeah, that sounds good. And the buffer i dot image is going to be 0. Right? And what we can do down here when we actually use it, this is a transformer complex, auto const, in fact, std array of floats, wt analysis, window size, we're just going to transform it. I can't be asked doing it, so we're just going to do it. Begin and so we're going to begin the transform complex, end of transform complex to the begin of transform. And what we have here is a complex std complex of float. In what we do is we return in the real. That is it. That's what we're going to do. Now transform will work. So just to make sure, like, this will transform the complex output of the FFT analysis into an array of floats representing the frequency. I'm not sure if energy is the right one, but amount, I guess. Energy means something else. Is the energy of a sine wave, or sorry, of a audio wave, or any function for that matter, is the Fourier transform of 0. So yeah, the frequency amount into representing the frequency amount. Yeah, that's it. Now we should be able to do it, right? So I am from India. How to go abroad for research purposes in cybersecurity? Dude, I don't know. I do get asked that a lot of times, and to be honest, I was lucky that my parents moved to the UK when I was kind of young. But I would say just, start doing some research in India, I guess. See if you can get like a remote job online, and then try and kind of interview for other roles in other countries. Purpose. I mean, obviously, if you want to just do research, you can always pay for universities here and whatnot. But that is the expensive route. Not everyone can afford it, right? So instead of res, you can use std norm. No way, dude. Thank you. std norm. Does that work? Where's that from? Is that from CMath as well? Let's see. Thank you. Dude, I wish I could pronounce the name, man. You've been helping me quite a lot. Well, I don't know what your name is, dude. It's in Hebrew, I guess. Is that correct? But thank you. It is in complex as well. Oh my god, yeah, it's in complex. How did I not know this? You can kind of tell how often I use the complex header. Never, that is. It's Daniel. No problem. Oh, thank you, Daniel. Thank you very much, dude. So, std norm. Okay, beautiful. Build. Yeah, that's a good question. Does anyone actually use the complex header a lot? Because I've honestly, except from this project, in my entire 7, 8 years, 7, 8 year career of C++, I've never, ever had to use the complex header. I tend to just implement the complex like struct myself, to be honest with you guys. So let's see what it looks like now with that cosine Hann window thing, at least. It still looks shit. Nah, it did not fix anything. Let me see one thing, right? So M elements. Okay, 0.071. If we run that, okay, basically 0, a very small value, that's fine. So it is, yeah, the Hann thing is kind of working, but why are we getting just gibberish data? We're just getting gibberish. Huh. There is a bunch of like conversions here happening between one type and another. Okay, what if I just did the normal part instead of the norm? Am I just misunderstanding what actually the FFT returns? FFT returns complex numbers. Dude, I studied this at uni and I just can't remember. I know that one of them is the cosine coefficient and the other one is the sine. Is that the correct assumption though? Oh gosh. Describe all possible inputs. It needs to be able to represent phase as well as amplitude. The phase is represented by using complex numbers. For example, suppose your FFT is a signal constraining of only one sine wave. Depending on the phase, you might get an entirely real FFT as a result. But if you shift the phase of your input a few degrees, how else can the FFT output generate that input? Yes, the amplitude and phase. Magnitude of complex numbers. If you care about its intensity, the magnitude of the complex number is sufficient analysis. Yeah, that's what I thought. This is the assumption I used. So I only care about the intensity of each wave, of each sine. So the magnitude of the normal, right? The norm should be enough. If you want detail to derail your focus, look at what I send on Discord. I don't, but I will. I'll look at it. What did you send me, dude? This is the keyboard layout. Okay, let's check it out. So yeah, you got the American layout, I guess, right? Wait, what? Oh, you got a different one to mine. Wait, this is what your layout is? The keyboard you bought? That is definitely different to mine. I have home separate. Oh, I see what you mean. Yeah, you got home and separate end keys. I thought I did as well, though. No, I don't have home anywhere. You are correct. But anyway. See the coordinates of a result vector that point to a length and a direction, angle, magnitude, and phase. Oh no, it's saying that the magnitude is the first one. All right, interesting. So if I just use the real part instead of the norm, right? So just, we don't even need a preprocessor here, right? We remove that. So we're saying that we want to just get the real part of it. Yeah, yours is merged into numpad. It is, yeah, you are correct. End is number 1 and home is 7. It looks different for sure now. But does it look nice? That's the question. No. It looks better, for sure. Let me do one test though. So if I want to know if there's anything wrong with the analysis code itself. So, if instead of reading the raw audio data, so raw audio, I think it is, where else do I use it? If I got a result like this, I would open a new branch and name the LSD. Yeah, dude. It must be crazy to do acid and watch this. Don't do drugs, kids. I don't condone the use of drugs. Just putting it out there, in case my employer is watching me or something. So yeah, instead of reading stuff, right? So I'm just not going to read it. I'm just not going to read it at all. What I'm going to do is I'm going to create I'm going to generate some audio data for a sine wave and then see if we actually get that, right? Shall we do that? Right, so let's do that with Python actually, because we can kind of see what's going on. So if we just added a new B in here, there you go, cell or something. So we're going to use np.sine, is that correct? How does np.sine work? I don't know. So x, angle in radians. All right, I see. Order k. Right, so that's the angle in radians. So what we need to do is, first of all, generate np.arrange or something. The stop would be 2048, I guess. Oh, in fact, 1024. I'll just double each sample later. We got that, and then if we get something like, yeah, that should be np.arrange divided by, yeah, let's do some numbers here, number crunch, right? So this is the size, so n. That's going to be something like 1024. It's the total number of samples we want. N minus 1 is going to do this, so it gets between 0 and 1. And if I then times it by pi, I think we have that, or 2 pi, 2 times pi, do we have np.pi though? Oh yeah, np.pi is a thing. Right, okay, good. So we should be able to do something like, a sine wave is equal to np.sine that. And then if we plt.plot sine wave, okay, good. So this is one sine wave. So the frequency at index 1 here, or 0, 0, 1, 1. Yeah, a 0 would be full on, right? So we only expect to see 1 bar. If we repeat this n times, then the frequency at index n will be full on as well, right? So let's just do that test. So if I say I wanted the 10th frequency to have the entire energy in my sample, I would want something like that. So n times I guess there, arrange n times 10. Wait, let's think now, because this is quite interesting. So I want this to go up to 10k. So I guess times 10 times that. There you go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly. Good. Amazing. And what we can do now is use some of this shit here. NP float 32. Now, how do I save it from a numpy array? Oh, let's use AI again. So save numpy array. Also, let's change this to as type np.float32. Great. Save numpy array to a C++ float header. Let's see how we can do that real quick, because I can't be bothered figuring out the code for it, but I can obviously do it, so. Okay, dude, just give me the thing. Shape, const guards. Oh, this is actually creating me the entire freaking... Can I just print it? Can I just print it? I'm just going to print it and then... Okay, now. Save np array to a text file or readable. Save text is the one. Okay, beautiful. That's what I wanted. So my array, we have sign 400, sign 1024. Ah, that's the thing though. We actually want, oh gosh, what happened here? I actually want the size to be 2048, right? So I want to essentially double every single one of my, I'm just going to post it here anyway. Every single one of my sample. What happened? What the hell just happened? Yeah, one thing I found is that like the Vim macros don't work really well with this IPython notebook view of VS Code at all. So if you're using Vim, you're gonna find it very difficult to use that. Yeah. So again, how to duplicate every item in np array. np repeat. And repeat and 2, right? So if we do plt.plot, sine wave. Okay, good. So yeah, we got about 2,000 out. That's good. Yeah, if I was to save this now. So for raid, limiter. Okay, right. So in theory, do we have this? Oh, right. Yeah, we do. We do indeed. That's good, because now it's very easy for me to just copy this, right? This whole thing into a header somewhere. So where's my main? all of this just so I can put some freaking test data on my analyzer and make sure that it's giving me the right format at the very least. So if I put it here, right, if I create a new file, there's HTTP. Okay. Include the array here, gonna define a namespace. I don't really need this because it's just a test, really. Okay, that's inside there, which means I have to do an std array of float and 2048. What is this? This is an array. This is a sine wave, yeah, sine 10, I guess. And again, another fucking one in here. Format. And beautiful. Bob your uncle. Oh no, did not format. It did not format. So what we're gonna have to do here is, okay, right, so we queue at L, go to the end of the line, add one, go next one, queue, and then literally do this over 1,000 times. Why does it take so long for Visual Studio to actually run the Vim macro? This is ridiculous. Absolutely ridiculous. Surely there must be a quicker way of doing that. Good thing is that we only have like 1,000 items or so. What notebook is that? I don't like Jupyter Notebook, so I would like to try this. This is just the Visual Studio. It's still like a Jupyter Notebook, but it's just on Visual Studio by default. It does support it. How many more do we have? Oh, another 1,000, of course. So there you go. But yeah, I mean, if you install Jupyter Notebook on your machine to run Python, and you create an IPython notebook, in other words, a Jupyter Notebook file, you can just open it with Visual Studio. It's less hassle, and you don't have to run the actual Jupyter Notebook server. Just use regex max. Maybe, yeah. I kind of like my Vim macros, even though it is a little bit longer. Oh gosh. And it may mess up like that. There you go, format document. God damn it, yeah. Line 10, right? So what's the problem here? Value line 10 isn't in a header file. Variable definitions in header files can lead to all the add definitions. I can inline this and you will be fine now. Okay, good. Or let's do a static inline or something like that. Yeah, good. All of this, again, I usually use it for semi-smart, find and replace. Because these regex max. Capture groups make me very efficient. Yeah, if you're talking about the find all, yeah, maybe I could have done it faster there. I know there's a way to select multiple lines and then do the same thing on every line of Visual Studio Code. I'm just not that into Visual Studio Code. Yeah, could have done it faster, to be honest, if I was. But we have the raw audio. What I'm going to say is that raw audio is now going to be equals to something else, right? I'm going to comment this out. And instead of that, I'm going to literally just include test.hpp, go back here, and do that. Now, this should give me some sort of sine wave on the screen. And it better compile. Oh, this is just the audio stuff. See, this is wrong. This is completely wrong. Oh no, this is just not analyzing it, never mind. Yeah, this is drawing the sine. That's quite right. It's actually quite nice. There's 10 sines here apparently. But, so analyze is not doing anything? What? What? That's what I'm getting, right? So analyzing is not doing anything. His input. His begin there. His output gets converted to the buffer, and then we return the buffer. Oh. Interesting. So what is going on here? Which, by the way, the kind of stuff that I'm expecting, I think there is a NumPy FFT. A NumPy FFT. There you go, there is one. The kind of stuff that I'm expecting is something like this, right? So if I do another one of these, no, don't save that. We have the sine wave, the FFT wave, I guess. So np.fft does that work? Yeah, it does. Of the sine wave. Object is not callable. Huh? Is it np.fft.fft? Don't tell me that is. It is. What is FFT2? Creates two-dimensional? Yeah, just one. That one. Sine wave. plt.plot. Wait, what does FFT wave look like? Ah, I see. So it is an array of complex. Real? Is that? There you go. So if we draw this now, plt.plot, this is what I'm expecting. Ooh. Is this what I'm expecting? Let me see one thing. So Fourier transform of sine, not sync. Oh yes, I remember. I don't remember the formula, but this is how you do it. Would love to say more, but super tired. Gotta go. No worries, GTX. Dude, as always, man, have a good night. And thank you for joining, man. Always have a great time talking to you. Have a good night, dude. I'm tired myself as well, to be fair. Like, I'm gonna call it soon. Just can't be looking at maths all the time. Phase spectrum is that. The magnitude spectrum. We have the minus and the plus magnitude for it. Okay, yeah. So the middle one is always kind of. Is that what we have? We've got two here. Interesting. Interesting indeed. So I kind of can see that. Yeah. Huh. I'm confused. I'm very confused. The Fourier transform of g sine t. So we have 2 pi times 10 at time. That's what we have there. The answer is pi over I. Or minus, I guess. Oh, dude, just to think that I used to do this amount of uni and then I just can't remember any of it now is depressing. Jesus Christ. Which, by the way, this is like probably the subject at uni that I did the shittest at. But on the bright side, believe it or not, is the one I enjoyed the most. Because I was finally able to kind of understand what the Fourier transform is. So we go into all of these like integration functions and, you know, learning how to properly integrate things and like do convolutions and whatnot. Now I just can't remember any of it. It's crazy. Classic unique experience. Don't remember anything after you're done. Yeah, but in your case, Robin, by the way, great to see you, dude. In your case, you've just finished uni, right? So we probably still remember most of it. Like, dude, this was 7, 8, oh, yeah, 8 years ago. Like last time I saw something like this. I just can't remember any of it. Like, I don't even know how to integrate e to the I theta anymore. You know what I mean? It's something that I just used to like remember like this. And now it's just depressing again. But does it look like we have something correct? No. No, because this is a sine wave. It's just drawing the sine wave itself, right? Which is kind of trash. Kind of trash. What if we didn't have this Hann thing, the Hann window? Let's try that. I'm great, super tired, so probably gonna go to sleep soon. Yeah, dude, I think everyone here is kind of super tired, including myself. So I'm also gonna go to sleep soon. I'm just trying to see if I can fix it for like the last 10 minutes, I'll be grateful if I can. If not, I'm gonna try and get some sleep as well. It's Easter tomorrow, right? I guess everyone's gonna have a nice and happy Easter and eat a lot of chocolate, like you should. I certainly spend a lot of money this week on chocolate. I have like 4 people in my family apart from myself. It's 5 overall. So every single one of them needs to have an Easter egg, and yeah. Turns out that shit's quite expensive today. Crazy. An Easter egg is like £10, a good one. See, still doesn't look right. So I kind of think it's something wrong with the actual analysis. That's what I'm going to take. So the KISS FFT thing, it's perhaps not been used correctly. Perhaps. So what do we get? We get the input. Maybe I'm using some of the buffers that I'm not supposed to. My Easter has been so boring. I have been on cat watch all week and I'm done tomorrow night. Oh no, dude. Sorry to hear that, man. But try and get some nice chill time tomorrow. I'm trying to do that as well. I'm going to try and stay away from the computer the entire day, but it's difficult because I'm actually quite enjoying this project. I'm not sure if you get that, but when I'm enjoying writing something, I just have to do a little bit every day. And it's funny because it's frustrating sometimes, like this now. I have no idea what's wrong. I'm just trying to figure out. Hoping that I fix it by the next stream, so you guys are not too bothered. Or too bored. But yeah, I mean, having a day without the computer is going to be good. I'm soon going to go on holiday as well, which means I'll be away for a week at least. I mean, I do that nowadays anyway. I only stream once a week, so you guys will not see me until I come back on holiday, so you might not notice that much. But that is the time I have for just not staying in front of the computer at all. I'm not even going to take my laptop with me. So that's going to be fun. Looking forward to it. Maybe I feel slightly overworked at the moment. I don't know. So a break is much needed indeed. Yeah, we get the buffer. We push it to the KISS input. The real and imaginary numbers. Okay. So the input in is the key KISS input. Input out is KISS output. We transform begin KISS output to the end of KISS output back into this buffer thing, right? In.real, in.imaginary. Put the post processor and return the buffer. So I don't see anything that's wrong with this, to be honest. It should be doing the transform. KISS FFT example. So we allocate it, create an input array, output array, put the cave sample in. Okay, and yeah, okay. Case FFT CFG transform DC. Okay. So DC is always going to be in 0. So it looks to me as if, yeah, DC is always going to be the biggest one. Frequency domain, CF is the DC or the energy of the wave. And FFT, CF, wait. And the FFT, oh gosh, bin is a DC bin of the FFT and CX out and FFT over 2, the Nyquist bin if it exists. Okay. I need to figure out what these things mean. I can't remember. I don't remember at all. Real valued FFT. A real valued optimized FFT which takes real valued signals as input implemented in case FFTR. It returns the positive half spectrum and complex frequency bins. So I think this might be the actual function we want to use, the real valued one, I guess. Spectrum. Yeah. Yeah, I'm gonna have to figure it out because I have no idea. Anyway, guys, I'm extremely tired. I'm gonna leave it as a short stream today because I'm not getting much done. I can't think. I think you guys are quite bored. I'm trying to come home though. I have a new C++ project in mind that I want to build, which is not every day. Yeah, I guess it's not. Yeah. If you need any advice, dude, let me know. I can help you out. But on that note, guys, I'm going to call it here. I'm like extremely exhausted. It's been a long day for me, even though I haven't been working, but I've been doing other stuff. Yeah, I hope you guys have a good evening. And I guess I'll see you next week. It's going to be a very difficult week for me to stream, I'm going to be honest, because my wedding is actually, well, next week, right? So I definitely will not be streaming on Saturday because that's when I'm out. But I might be streaming the days before. Who knows? No worries, dude. Thanks for the stream. No worries, dude. Thank you for joining again, as usual, Robin. Yeah, so I'll see you guys later, and bye-bye.